Welcome to our podcast where we dive deep into the world of AI and machine learning. Today, we're exploring the fascinating topic of fine-tuning large language models, specifically focusing on Meta's Llama. You may be wondering, what exactly does this involve and why is it so exciting? Well, stick around as we break it down. To kick things off, let's talk about what it means to fine-tune a model like Llama. Fine-tuning is essentially the process of taking an already trained model and adjusting it to better perform on a specific task. Imagine you have a talented musician who can play various instruments expertly. Fine-tuning is like teaching them to master a specific song or genre. Now, this fine-tuning can be accomplished using various methods, such as composable fully sharded data parallel, or FSDP, and parameter-efficient fine-tuning, or PEFT. These methods are particularly relevant when we're working with large language models that require significant computational power. So what's FSDP? Think of it as a way to make training large models more manageable. Instead of loading an entire model into memory, FSDP breaks it down into smaller parts and spreads it across multiple GPUs. This allows researchers and developers to work with larger models without needing a supercomputer. Wow, right? It's a game changer for those of us eager to push the limits of what AI can do. And then we have PEFT. This method is all about efficiency. It allows us to fine-tune models with fewer parameters, which means it requires less data and less computational power. It's like giving your talented musician a new instrument with built-in settings that let them play that particular song flawlessly without needing to learn everything about music theory from scratch. Now, why would someone want to fine-tune Llama specifically? Well, it has applications in various fields, such as summarization and Q&A. Imagine needing a brief rundown of a lengthy article or getting quick answers to complex questions. Fine-tuning allows Llama to understand context better and deliver more accurate responses. Here comes another interesting facet: how these techniques support single-node and multi-node GPU setups. In simpler terms, whether you have one powerful computer or multiple computers working together, these methods will adapt. It's like choosing between sailing a single yacht or a fleet. Both can get you where you want to go, but the approach may differ based on your resources. If you're wondering how one might go about this fine-tuning process, well, the support for default and custom datasets plays a crucial role. Researchers can train Llama on pre-existing datasets or tailor it to their unique needs, making it versatile for various applications. Let's take a moment to consider, why is this flexibility significant? In today's world, where information changes rapidly, having an adaptable AI model that can learn and respond to specific requirements is invaluable. It's like having a conversation with a friend who knows exactly what you're interested in, rather than just rehearsing general knowledge. As we wrap up, it's clear that fine-tuning models like Llama, using methods like FSDP and PEFT, opens up a world of possibilities. It pushes boundaries, allows for broader applications, and makes the tech more accessible for various use cases. So, what do you think? Could this kind of fine-tuning represent the future of AI interactions? It sure feels like it to me. Thanks for joining this episode of our podcast. We hope you've learned something new and exciting about the capabilities of AI models today. Keep exploring, and we'll catch you in the next episode.